by which the software has been developed. Now, geometric transformation, it is again a very important from the user's point of view as well as the developer's point of view. So, because geometric transformation plays a central role in the model construction and viewing, and they are used in modeling to trace the location of the object relative to the others. And commonly used geometric transformations are the translation, that means a particular object will move linearly, either x direction or y direction or both, or if it is a three-dimensional case, it will move x, y, z direction or in combination. So there is no rotation of the CG will translate. Now rotation means there is no such XYZ movement. Rather, it is a rotation about X, rotation about Y, and rotation about Z will be taking place of an object with respect to a reference. Now, both this thing it can be represented by the matrix. So for translation, the matrix is or mathematically you can represent the translation by 4 by 4 matrix, which is known as homogeneous transformation matrix for translation. So next will be your rotation. Rotation again, there are the different concept in rotation. Rotation about the origin of the coordinate frame, rotation about the arbitrary point in the arbitrary point in a geometric area, or rotation about a x-axis, rotation about y-axis, rotation about z-axis, or rotation about any arbitrary axis. So there are the different mathematical formulation or mathematical representation of different type of rotation is there, and all basically known as rotation matrix. So it may be 3 into 3 rotation matrix, or it is 4 into 4 rotation matrix, or it depends on the whether it is in 2D case, then it is a 2 into 2 rotation matrix. Means the rotation matrix size is 2 by 2. If it is a 3-dimensional case, 3 by 3. If it is a homogeneous representation, then your dimension will increase by 1. In case of a 2D, the rotation matrix, homogeneous rotation matrix is represented by 3 by 3, whereas in the 3-dimensional case, homogeneous rotation matrix is represented by 4 by 4 matrix. So these are the some mathematical derivation is there, so it is not possible here to explain this one. Similarly, the scaling also represented by a matrix. So this is called the scaling matrix. Mirror reflection also represented by the class of homogeneous transformation matrix, or it may be the combination of the above 4, any combination. So this is in nutshell your geometric transformation, but huge mathematics is there in the back side. So now, when you like to do this thing at the user's point of view, no need to think whether the whatever matrix is working backside. Only thing is what to select for translation, for rotation, scaling. What are the syntax for doing that one when you use the CAD tools? No need to think of which matrix is running backside. That is the developer's job, but users will only know the syntax. Whenever you click the rotation, you have to choose either a point. If it is a 2D case, if it is a 3D case, you have to choose the axis, and you have to give the amount of rotation. That means that is called a translational parameter. That is called a transformation parameter. So only thing you have to know from the user's point of view, in case of a translation, transformation parameters are displacement along x, y, and z direction. For rotation, theta is the transformation parameter. For scaling, transformation parameter means the scale factor is the transformation parameter. For the mirror or the reflection, you have to choose with respect to which point or with respect to which line you like to do the mirror or reflection. So that's the user's point of view you need. This is the transformation parameter to choose during your solid modeling. Now I like to tell you the one important aspect from the industry point of view. The industry the most of the product development industry, whether it is the aerospace or automobile or any other consumer product development, that they are now last 20-30 years user of the CAD. So without CAD, no such company will sustain in this competitive world. And that using the CAD, what actually they are doing? They are doing basically virtual prototype. So I like to explain today is the virtual prototyping in respect of the product design, or more specifically machine design. And tomorrow I'll explain that once your virtual prototyping is over, what industry is doing? They are doing going for the rapid prototyping. So first I like to tell today what is virtual prototyping is, what are the scope of that, what are the things you can do using this particular concept of virtual prototyping. An example, whatever I will take, that is in respect of product design and more specifically the machine design problem. Now in virtual prototyping, keywords is the virtual and the prototype. Now what is prototype? For the any product development, prototype is very important term because by prototyping we mean either a full scale model of the product may be machine, equipment, apparatus, vehicle, or any other mechanical system used when prototype is used for evaluating the form, evaluating its fit among the different components, and the performance or the functional testing or performance testing. So, purpose of the prototype in conventional product design and development process is to verification of the design concept. So whatever concept or whatever preliminary design is conceived by the designer, that has to be verified from the different angle. And for that, prototype is required, and so that other people, other experts can see your prototype and check your design concept. And they also tried for the evaluation of the design alternatives. Different expert from the different field will sit together, see your prototype and evaluate is there any alteration possible or not. It also allow using the prototype, it also allow human being can use his sensory evaluation of the product. For example, aesthetic feature they can evaluate. Aesthetic consists of form, color, finish, all these things they can evaluate if your prototype is in front of you. The expert can also check its feeds, its ergonomics, that I already explained the terminology. What is aesthetic, ergonomics, I have already explained. So that will evaluate by human sensory channel. And also a prototype is used to test the product functionality. Used to test the product functionality, whether a product will performing as per your desired requirement or not. That you can check over the prototype. Prototype also used to evaluate the assembly procedure, its manufacturability, its maintainability, safety and reliability. All these things, any product development industry, you can visit, then you can see this is the things they are doing. That before launching any product, whether it is automobile or household appliances or aircraft, whatever may be, you have to check its assembly procedure so that it can be easily assembled, easily manufacturable, and also the after sale or maintenance, safety, reliability, all these issues has to be evaluated before launching any product, and that is why over the prototype you have to evaluate all these things. Sometimes prototype is also used for training and other study purpose. So in order to for a particular product or particular machine, it is basically run by the operators. So operators or users training and other studies, for other studies prototype is required. Now question is, if you prototype means basically here we're talking about the physical, that means it is expensive, because if you like to develop the prototype physically, it can be expensive because there will be involvement of man, machine and material. That means ultimately there is the involvement of the cost and time to create a physical prototype. Now, as you know, the prototype after testing, after evaluation, it is the wastage. You have to throw it because it's the prototype. You have done this thing, sometimes destructive testing, sometimes non-destructive testing, and this is not a commercial product. It is for this evaluation purpose. That means you have to throw it. That means it is expensive. In order to manufacture that one, a lot of cost is involved, and that cost will be distributed to the ultimately product cost. No, when you like to sell any product in the market, this sub cost which was in a wastage will be distributed over the product, over the product which you like to sell. So that is why, as you know, you have to reduce the cost of the product. That means you have to reduce the prototyping cost also. Now, because as you know, these are the challenges. You have to develop your product with the shortest, lowest possible cost and shortest possible time. So now question is, what will be the cost effective alternative of physical prototype, because I already mentioned physical prototyping is expensive. So what will be the cost effective alternative of physical prototype? And now answer is virtual prototyping, by which you can reduce the cost of the product development drastically. Now, virtual means digital, and prototype purpose you already know. So, for virtual prototyping, first you have to develop the 3D CAD model. That CAD model is imported or taken open into your digital mockup, where you can do fitting simulation, where you can do kinematic simulation, and so on. That means you can simulate its form, its fit, its function over the digital model. Now, the purpose of which the prototype are used will be the same, irrespective of whether the prototype is your physical one or the virtual one, that means the digital one. Now, virtual prototype must serve the same function of the physical prototype. Now, what we mean by the virtual prototype and virtual prototyping? Virtual prototype is a computer simulation of a product that can be presented, that can be analyzed, and that can be tested from the concerned product life cycle aspect, such as design, engineering, manufacturing, assembly, maintenance point of view, service and recycling point of view, as if on the real physical model. That means the whatever you like to do over the real physical model or physical prototype, same thing you can do over the digital model or the computer generated model. So that is why virtual prototype is a computer simulation of a product, that means the digital product that can be presented, that can be analyzed, that can be tested from the concerned product life cycle aspects, such as design, engineering, manufacturing, assembly, maintenance, service, and recycling, as if you are carrying out over the physical model. In other words, the construction and testing of virtual prototype is called as a virtual prototyping. Now, virtual prototyping is the analysis and simulation carried out on a fully developed computer model or the digital model, therefore performing the same test as on the physical prototype. So whatever you can do over the physical prototype, same can be do over the digital prototype through computer simulation, through certain tools, and that tools is nothing but your CAD CAE tools, by which you can do analysis, you can do simulation over the digital model or the 3D model. So in short, virtual prototyping is about presentation, form, fit, and functional testing and analysis of 3D CAD model prior to creating any physical prototype or physical model. Now, the form in, as I mentioned, virtual prototyping is form, fit, and function. Form implies that prototype is used for visualization, where fit requires the dimensional accuracy, and prototypes that are used to check the assembly fitting, whereas the function means the prototype will be used for function checking, where a load is applied to the prototype as it would be applied to the real parts. Now, this will be very much useful in concurrent engineering concept, because the concurrent engineering concept expert from the different field will sit together and they will, as you already know, they will review your product from the different angles, from the assembly point of view, manufacturing, aesthetic, ergonomics, maintenance, reliability, safety, capacity planning, functional testing, tool design, and cost point of view. They will evaluate, and they means the different expert from the different problem domain, or like R&D, engineering, manufacturing, quality control. That means if you can represent your model or your concept or your design in a more realistic way, then they can easily conceive your product, and that is why visualization of the product is very important. Otherwise, you cannot give the proper suggestion or proper advice. So visualization is very important, and That means from the designer's point of view, communication of your product to others.
Hello, hello.
Found anything in the mistake, then it will be the huge cost involvement. Instead of that, if you can do the feed and interference checking over the digital model, it will save a lot of money, a lot of materials. So next important function of the virtual prototype is the virtual testing. So testing and verification of the functions and the performance that I will explain, and that can be done by the solver or that by the motion analysis like kinematic and dynamic modeling of your product, by structural and physical phenomena analysis using the FEM and CFD. So structural and phenomena analysis by which you can do the virtual testing. So another important function nowadays of a virtual prototype is the manufacturing evaluation, and that can be done by different way. One is your by assembly analysis, by checking its assembly sequence or assembly analysis, and also by checking the manufacturability and the maintainability aspect. So these two will cover within the domain of manufacturing, within the domain of manufacturing evaluation. Next is the human factor analysis, that means ergonomic analysis. That also carried out over the virtual prototype. Now, first I like to explain the visualization and communication. Right inside the top corner, I have shown a ball throwing machine which is developed by us, and it is digital model. And by applying the proper color rendering and the background, it looks like a real machine in the say nearby your field, or in the backside there is a wall. So visualization model are used for examination of the form as well as the appearance by the team member of the concurrent engineering concept. So this visualization model plays a crucial role in communication of the product information between a variety of people in concurrent engineering concept that I already mentioned. And so that the CAD software uses the 3D model to provide the photorealistic model by full color, natural texture and appearance, and by this method you can communicate your product more effectively to others. Visual perception and appeal can be evaluated for the digital model with a variety of forms regarding the product layout, describing the overall product components and subassemblies and their associated colors and surface texture. So virtual prototyping visualization provides the dynamic 3D viewing of the model from any user specified angle and orientation. You can do the fly through or you can do the walk through over the digital model, so that you can see your product from the different angle.
So either way,
So this feature is available in virtual prototyping. So you can fly through or you can walk through that. I will show you some video here. So modern visualization software can simulate interactive navigation capabilities that I mentioned, walking or the flying through the complex assemblies to enable effective and accurate visualization. So these are the thing that simulated views that you already know. For example, this one, you just see the interior of the car. So can you see this one?
Yes, sir.
Let me, I just like to share the video of this one. I don't know video here, it is not working. Let me stop sharing here. I like to share my screen and let me check. Just a minute, just check it. Share, share content, share the screen. Can you see this one?
Yes, sir.
Can you see the video?
Yes, sir.
No, sir. Video no.
Is it visible the video part?
No, sir. No, sir.
Yes, this sir.
Few, few of you can see this one, no?
Visible.
Here I like to see that this is not the physical prototype or interior of the dashboard of your car. It is basically a digital model, but it has been represented by applying so beautifully the color, your texture, and the rastering and lighting, so that it looks like a real interior of the car. But it is purely digital model. So this is the power of visualization, the power of CAD tools by which you can visualize your product in a more realistic way.
Voice is coming. Hello. Your voice is not coming, sir.
Is the video coming? Sridhar?
Yes, sir.
Can you
Video
see?
coming, sir. Voice is also coming. Okay, sir.
Uh, so see the power of the CAD tools as well the communication tool using virtual reality techniques. So more realistic way you can evaluate your design. If any bottleneck, then you can rectify in the digital level itself. So this you have already seen. Next is and now these virtual reality tools not only used by the mechanical engineering product developer, it is also used by the civil engineering department, because before creating the actual tower of a real estate business, actually developing the tower, physical means apartment, what they like to do, they used to develop the CAD model of that one and either giving the proper color, texture, and they had developed a more realistic way. Then in virtual environment, they call the customer and you can walk through over your digital flat. You can move over the staircase, you can move over the floor of the your flat. So this way they like to attract the customer by showing the your digital model of your apartment, and by using the virtual reality tools. So virtual reality tools is not only used by the mechanical engineering domain, many other domain including the civil engineering domain they are also using. Now in mechanical engineering, one important thing you already know that the product have a moving parts. Now in moving parts, fit and interference checking among the mechanical assembly is very important in any product development or mechanical product development, whether it is automobile or aircraft. So, in any mechanical assembly, it might be clear where and how well every sub assemblies and or component fits with the rest of the product components and the parts. So, fit and interference studies contribute to reducing the cost of the scrap and rework arising from the poor fit, and it can also improve the part interchangeability. So fit and interference assessment is generally an iterative, time-consuming and error-prone process that would benefit from being replaced with a virtual prototype using the 3D models. So using virtual prototyping, the interference can be evaluated automatically with a great accuracy and speed, and resulting in the listing of all interferences. And it is also possible visually to inspect the virtual prototype where clearance and interfering in area of the CAD model can be highlighted with the different colors. So I am showing you here the two things for checking the interference. And one example I like to tell you here, that accuracy of the virtual prototyping tools for fit and interference checking has increased so that increased such a high level that one of the big aircraft, Boeing 777, as the first commercial aircraft designed 100% digitally with solid model or 3D model, which do not require any physical prototype to obtain the accurate fit. That meaning is to get the accurate, to check the accurate fitting and interference of the big aircraft, the Boeing 777. So whole fitting check has been carried out over the CAD model or digital model before manufacturing the physical prototype. So that means it is drastically reduced the cost involvement. They have found a lot of mistakes that has been rectified, that has been found in digital level and rectified in the digital level. So cost involvement has been reduced drastically. So from this case study or from this example, it is clear that CAD CAM-C tools has its performance or its effectiveness is increased such a level you can do many things over the digital model, and that is known as basically virtual prototyping. So increasing the power of virtual reality and virtual prototyping with the new haptic applications and interface may provide a solution through simulating the sense of touch. So for example, I don't know again whether I like to share the screen. So I like to share my screen. Uh, can you see this one? Hello? is it visible?
Yes, sir. It is visible.
See the difference here. When there is no such effective CAD tools or virtual reality tools, that time they used to do the fit and interference checking physically. So side by side, I'm showing the way they used to do fit and interference checking physically the long back, but same thing they are doing now digitally. So next I like to explain the third most important function of the virtual prototyping is the virtual testing. That means testing and verification of the function and performance over the digital level. Now prototype are used frequently to verify the functionality and performance of the various feature of a new product during its development cycle. So virtual prototyping relies on the 3D model to create accurate model that are complete and comprehensive in terms of both detailed geometrical as well as the non-geometrical, that means topological information, and resulting in the wealth information satisfied the data needs for the advanced computer-aided engineering tools for carrying out extensive analysis and virtual testing. So in order to carry out the virtual testing, the CAD-C tools required are your multi-body dynamic analysis tools, finite element analysis tools, and computational fluid dynamics tools. So these are the three important tools required for the virtual testing of a product or of a mechanical system. So virtual prototyping of the full vehicle or the full vehicle system analysis and simulation. So these are the performance has been this of the analysis has been carried out over the model, dynamic and stability analysis, vehicle durability and fatigue analysis, noise and vibration analysis, crash worthiness and safety analysis. For example, here you might know for the automobile or for aircraft, there is a test called the crash worthiness test. Means if a particular automobile will hit with the other object, due to this hitting, what should be the condition of the rider or the drivers and the passengers? And whether your safety bag will open or not properly, and what should be the design feature to incorporate so that the impact energy will be absorbed by the structure itself, so that less damage has been taken place by the human being. So that type of testing has been carried out, that by hitting any particular object in the wall or artificially created walls and something like that, that is called the crash worthiness test. And obviously, if you carry out the crash worthiness test physically, by changing the parameter like speed, by changing your obstacle behavior, obstacle property, then let us say you have to carry out say 80 numbers of crash worthiness test. Now each crash worthiness test, that will be damage of the car. That means you cannot use the same car for the second test. So that means you need 80 cars, and then after doing this one, it will be the destructive testing. You have to throw it away, and the result you are getting based on that you change the design. But same thing if you can do over the digital model, then no need to Obviously, whatever you do in the digital model for physical verification, you have to check that one. Maybe checking is required 4 or 5 models. You would digitally you just simulate it. Then for verification, because any simulation work, physically you have to verify it, and for that 4 5 cache ordinate is sufficient to validate your simulation result. If it is okay, then same type of simulation you can do by changing the parameters. No need to do for the 80 times of the same test with the varying parameter. Rather, you just do 5, validate your digital model or digital simulation model and carry out. So that means it will save the cost of around 75 numbers of car. Although the software cost is there, but still it is the cost effective. So a similar type of thing has been carried out in the mobile drop test. No, previously mobile there is a drop test, that is also destructive testing. That you can do over digitally. So using multi-body dynamic analysis tools, the simulation results can be recorded using the powerful animation tools and be replayed at any time later. So kinematic performance is to verify the proper geometry of the motion as intended for the design. So these are the some example landing gear simulation, and here we have done some tractor simulation where it is moving uneven terrain, how CG is moving with respect to time, whether it is CG is within the support polygon or not, for stability analysis that you can check in digital level, and according to change any design changes is required. So this is a part of your virtual testing. So this is the example we have solved in the tractor simulation using the Adams. So 3D CAD model inputted the Adams. Fly over the ball so that after pitching it will take turn, either left turn or right turn. So that simulation can also be carried out in Adams software. So that has been shown here. So it is a very interesting application of the your motion simulation tools in respect of the machine design like this, the cricket bowling machine. So similar kind of things used to do in a different industry for their product. Now, for the structural and physical phenomena analysis, most accepted and widely used virtual prototyping tools I already mentioned is the finite element method and computational fluid dynamics. As you know, the finite element method, it basically breaks down the complex shaped object into large number of simple shaped element, that is the finite element, which is small but not infinitesimal, but part of the mechanical structure being modeled that incorporates the complex strength of material formulation or the theory of elasticity formulation into relatively simple geometric shape, and behavior of the each of the small element is readily predicted by a set of mechanical mathematical equation, and summation or assembly of the such individual element behavior produces the predictive mechanical behavior of the actual object. Finite element analysis is the solution of the finite set of algebraic metric equations that approximate the relationship between the load and deflection for the static analysis, and it calculates the relation between the material property and the structural performance to predict the behavior of the structure. And using that, you can do a lot of simulation, a lot of virtual testing, like crash-worthiness state that I like to show you. That is basically application of finite element method. So main application of the finite element analysis comprise the following areas, like structural integrity analysis, including the fatigue prediction under the various loading condition, static and dynamic stiffness analysis, transient and vibration analysis, for acoustic analysis, for predicting and avoiding the acoustic problem, like eliminating the transmission gear rattle in automobile application. It is also used in thermal, electrical, magnetic and other domain or other couple phenomena, and that is why nowadays multi-physics based finite element solver is ANSYS or the COMSOL, so that they are now called as a multi-physics solver. So combining the dynamic motion simulation capability with the finite element, that means multi-physics, by several commercial virtual prototyping tool has resulted in powerful dynamic loading simulation that provide structural behavior like stress, vibration and noise, and the geometrical deformation and the failure prediction. So typical applications in respect of mechanical engineering in the automotive design, that includes suspension design, vehicle dynamic analysis, braking studies, prediction of the chassis behavior on acceleration, assessment of durability, engine design and simulation, crankshaft load prediction, powertrain design and simulation, crash worthiness test, safety state, all these things you can do using this finite element solver or multi-physics based solver. So that here the crash worthiness test, here basically it has been done by finite element solver. So this is basically application of CAD model along with the finite element solving tools. So other than that, I like to show a few more examples. So I think you can see this one. So how the motion simulation has been carried out. So whatever I am showing you, so that is the digital model, not the physical model. This one is the digital model. It has been been done over the CAD tools. Can you see this one, Dr. Ashish?
Yes, yes, sir. I will see.
Okay. So these are the digital model of the your Range Rover.
Okay.
It's not a physical one; it's a digital model developed in CAD software.
Oh,
Now, motion simulation has been carried out over using the CAD C tools, motion solver. That means it's the part of virtual prototyping. So this is called virtual prototyping. This is the one activity in virtual prototyping. Everything is digital here. Nothing is physical. Here also, these are background is basically picture, but ground there is some property. Let me see. So I like to show two more so that what a stretch we can see. Can you see this one?
Yes, sir.
So this way that virtual testing in the virtual prototyping environment has been carried out. This. I think you can see this one also, no helicopter.
Yes, sir.
So in both computational fluid dynamics as well as the motion simulation, it will combination couple problem. Both mechanism simulation as well as the computational fluid dynamics so that it can fly. So using digital model, they can do this sort of virtual testing. So that I already mentioned that computational fluid dynamics is another important virtual prototype tools that is used to simulate the flow, to simulate the heat transfer of the fluid. So now CFD provides increasingly more reliable prediction of the movement and the velocity, temperature and pressure contours and distribution pattern inside the system. And this is achieved by solving the Navier-Stokes transport equation using the conservation of the mass, energy and momentum. Now, next purpose of the virtual prototype or virtual prototyping that the digital model. No need to do the physically before physical testing. You can do digitally. For that, again, the tools required is finite element method and computational fluid dynamics. So virtual prototyping should comply with the requirement of the concurrent engineering and must therefore allow simultaneous product exploration and collaboration by the various engineering teams Virtual prototype evaluation includes prediction and simulation of the manufacturing process and production planning, both during the conceptual design and detailed design. So computer-aided process planning, again another important area. So that is a part of manufacturing evaluation. Process planning involves the selection of the type and sequence of the manufacturing operation that are needed to create a component effectively. So manufacturing process simulation is needed to verify the capability of the each of the manufacturing processes to achieve the DZ geometry, to achieve the DZ quality of the product. And for that, there are metal casting simulations tools. There are the metal forming simulations tool. So for for casting simulation, obviously CFD will be taken to the part. It is based on the CFD, computational fluid dynamics. But the metal forming simulation, it is based on the finite element analysis, and there will be metal cutting of the simulation that is also in finite element analysis. There are the many softwares, CAD tools or CAD CA tools is available to do this one. And tool and die design is obviously the another important areas in manufacturing evaluation that can do digitally or virtual environment, and that is why this is the part of your virtual prototyping. So the last one I like to mention here, that another important aspect, many more is there, but these are the most important aspect in virtual prototyping, that the human factor analysis. So as you know ergonomics, I already given brief introduction of the ergonomics in the very first class. So now you can easily apply to the human factor analysis or the ergonomic analysis that can do over the digital model using the CAD tools. So manufacture of the product may involve handling, assembly, packaging, and maintenance of human operators. So human factor aspect of manufacturing, assembly operation, maintenance procedure, component accessibility, ergonomics, safety, visibility, etc. can be studied extensively using the virtual prototyping techniques by developing the full-size digital mock-up of a product together with the life-size human model. This is the human model which again digitally developed. Now I like to show you some videos here, or the animation, or the basically simulation result using the Delmia software, which is also product of the Dassault system, for doing this sort of human factor analysis. Then it will be more interesting and more clear to you rather than seeing only this one. Let me check. So let me try this one.
Sir,
So
pardon,
I
sir.
think you can see, I think you can see this one, no? Can you see this one?
Yes, sir.
So in this way, the human factor analysis can be done over the digital model, over the CAD model.
Okay. Yes, sir.
So no need to do physically, over the digital model you can do this. So another thing I like. Can you see this one? So here I like to show you another things for assembly sequence checking, and also in the human factor, human worker, how they will access a particular area. That checking you can do over the digital model of a big aircraft.
Hello, sir.
Hello.
Sir, again, after 2 minutes, they will automatically disconnect, sir. So we have to
Okay,
restart.
okay. Okay. And you go for finalization of your design, but ultimately you have to manufacture the product. Whatever you have designed, that has to be manufactured, and for that also you need some time compression technologies. So that means to reduce the time for real representation. So till now I have mentioned the virtual prototyping for the virtual representation of the product in a more realistic way, but still real physical representation is ultimately required, because you have to develop the physical model, the physical, the thing is physical model is required, or ultimately whatever you design, you have to develop the physical model. So for that also you need some time compression technologies, and such technology by you can design a such manufacturing technology which can take the CAD data and directly it will manufacture the product, and then it will compress the time, or time to manufacture will be reduced. So such manufacturing method are additive manufacturing. Previously it was known as rapid prototyping, but now its name has been changed according to methodology used to manufacture a product or component, and accordingly the now new name is additive manufacturing, where it is develop the product, physical product, directly from the CAD data. From the CAD data, it will directly manufacture the physical product, and that is why it has been shown below that from CAD data to rapid prototyping for real representation. Rapid prototyping nowadays known as the additive manufacturing. So that will, as we are using directly CAD data to manufacture, even for CNC machining, directly CAD data is used for the manufacturing. So you can call CNC manufacturing, which directly use the CAD data for machining purpose, is the part of rapid prototyping. And additive manufacturing is also part of rapid prototyping, full philosophy, rapid prototyping family. So the thing I like to here emphasize, or tomorrow I like to demonstrate, that is your additive manufacturing, where the CAD data is directly used for the manufacturing of the components. So here no such human intervention in between. It is the full integration of the CAD CAM. Additive manufacturing, which is also commonly known as 3D printing. 3D printing is the one good example and complete example of the CAD CAM technology, because 3D printing will not work, or 3D printer will not work without CAD model, because input for the 3D printer or additive manufacturing process is the CAD model, and using that CAD model data in that geometrical information, it will manufacture the product by adding material layer after layer without any human intervention. So that is basically your part of rapid prototyping. Today I'll cover the virtual prototyping. Tomorrow I'll cover the rapid prototyping part, taking an example of additive manufacturing. So any any doubt up to this? So anyone have any doubt?
Anyone having any doubt, so please ask.
So I have seen one hand has been raised a few minutes back, 10 minutes back maybe. I forgot that name.